So this is the review for summative number 6 in Algebra 2, and I'm going to go through a little more than half the questions probably on here. There's a lot of repetitive concepts. So I am going to attach the slides to this, but also the answer key to our Google Classroom, and you can access any of that at any time. So we are going to be factoring, we're going to be using our flowchart. Make sure you have that flowchart handy. And at the top of the flowchart it says to always look for common factors. So I want to do that in every question we encounter, and this is a good example of taking out the common factor. So common factors can be numbers, they can also be variables. I notice both of these terms can be divided by a 3 and also p squared. You want to take out as big of a term as you can. So factoring it out of the problem means the 3p squared comes out of the problem. We're going to undistribute it is the other way to look at it. And then you're going to write down what is left. So if you factored out a 3p squared from that first term, you're still going to have a 1p, which I will just write down p. If my pen will work. There we go. And then plus 24p squared divided by 3p squared. The p squareds will cancel, and you get a plus 8. Easy way to double check you did that right is to redistribute the 3p squared, and you should get the same problem all over again. Alright, so that is sometimes all you can do in a factoring question. I can tell that we're done because what's left in the parentheses isn't even a quadratic. And the only reason I'd be able to factor more is if it followed one of our factoring patterns, so either the difference of two squares or that trinomial factor. I'm going to let you look at number 2. It's a similar question, all on your own. Number 3, so back to the flowchart, I'm looking for common terms. This is a case where I don't have any common terms. So moving down the flowchart, this is a 1, 2, 3 term trinomial, and it says to use your reverse foiling process to figure out the factors. So I will start by writing down my 2 sets of parentheses, and we start with the first term. These first terms have to multiply to give us b squared, so that has to be 1b times 1b. And then jump to the end of the problem with me, and these back numbers have to multiply to 30. So positive 30 means the signs have to be the same, so either plus plus or minus minus. And when I'm looking through the question, I can see that it has to be plus plus. Now 30 has quite a few factors, so there's 5 and 6, which I think is the one we're going to use. But for the sake of process, I'm going to write down a couple other factors as well. 5 and 6, 3 and 10, 15 and 2, and 30 and 1. So this is the way the puzzle works. All of these red pieces will work for the end of the puzzle, but the middle of your puzzle says the arches have to add up to 11b. So this arch plus this arch has to add up to 11. So when I look at my choices, I'm thinking, how about a positive 5 and a positive 6? And please do get in the habit of showing your check on the arches. I think it really helps prevent silly mistakes. Also gives you a little muscle memory. So 6x, oh it's x, not b, hello, plus 5b equals 11b in the middle, which is exactly what I wanted. Alright, 4 is very similar. I'm going to leave that one for you. I'm going to move down to number 5. And here I notice I'm back to the top of the flowchart. All my terms do have a common factor. This time they have a common factor of 3. So if you divide or factor out that common 3, you haven't done any trinomial factoring yet, you're just taking the 3 out. So this is going to be one of those two-step processes. So k squared minus 1k minus 30. So now what I have left in the parenthesis, that's going to factor again using the reverse foiling process. So the 3 stays out in front of the entire problem, it's not going anywhere. And now we go back and we reverse foil. So k times k will give us k squared. And then, oh, this is kind of boring. It's 30 again, but this time it's a negative 30, so the signs are going to have to be one positive and one negative. So I'm going to kind of steal my numbers from up here. I got 5 and 6, 3 and 10, 15 and 2, 30 and 1. So again, it's going to be 5 and 6. I just have to be careful who's negative. If you want your arches to add up to negative 1k in the middle, keep that in mind, unless you don't bother with, if you don't mind guessing and checking, then just throw something down. But I'm going to look ahead. What if I did a negative 6 and a positive 5? Let's see if that checks out. That's a positive 5k. This is a negative 6k. And when you add those together, you get negative 1k in the middle. Very good. So this right here, this is our final answer. It did take you 2 steps. So I expect to see 2 steps when you're approaching a question where you do have 2 steps. 6 is very similar. You're going to have to factor out a common term first and then factor again. So number 7, 8, 2, and 3, these do not have any common factors, so you're ready to jump straight into reverse foiling. So this one's a little more complicated. That first term is 8x squared, so it could be 8x and 1x. Could also be 4x and 2x. and you have to make a choice right away. So we tend to avoid the ones that are far away from each other. We're going to try 4x and 2x. And then ignoring the middle for just a moment, let's jump to the end of the problem. My back numbers have to multiply to a -3, so I know the signs have to be one positive and one negative. 3 is prime, so it's 3 and 1. And we have to kind of play around with the order in which we place the 3 and the 1 because it's going to give us a different outcome. So at first, maybe I'm not sure. And I'm just going to place 3 and 1 in that order because I'm making a guess. So here's where the check comes in. I haven't even placed my signs down, and that's okay. So this outside arch is 4x right now, and this inside arch is 6x. And remember, one of them is going to be negative. So if I look ahead in the problem, and I want them to add up to a +2, that would work if I made the 6 the positive and the 4 the negative. So worst case scenario is you made a guess, you checked it, it didn't work, and then you just come back and fix it and check it again. I don't really give you too crazy a factoring question, so as long as you don't have like a little moment where you can't multiply, it shouldn't take you more than 2 or 3 guesses on any given question. All right, number 8 is very similar. I'm going to leave that one for you. Go ahead and check the key. Number 9, there's no common factor, so I'm moving down my flowchart, and I notice this is a binomial. So this, if factorable, would have to be what's called our difference of squares pattern. And this is the difference of squares pattern. It's a subtraction, and then it's 2 things that can be square rooted. So we sometimes call this the good twin, evil twin pattern. It's just like a cutesy name for us. It's not the official name, obviously. It's just helpful to remember things that sometimes don't sound very mathy. Alright, so good twin, evil twin pattern states that the way this factors, it factors into the pattern a plus b times a minus b. So the way you get your a and your b for that pattern is you take the square root of each term. So the square root of this term would be 3a. There's twins. And then the square root of this term, well, that's kind of boring. Square root of 1 is still a 1. So one's a plus and one's a minus. And that's how you factor good twin, evil twin, or the difference of 2 squares. I am going to do number 10 with you, just because I think that's a skill that we needed a little more practice with, judging from our last test. So there's no common factor, but this is the difference of 2 perfect squares. So using our good twin, evil twin pattern again, I'm going to take the square root of this first term. That would be 5x, 5x. And then the square root of this last term, which is 3 and 3. And then make one of them a plus and one of them a minus. So that, if you recognize that pattern, it should be a nice easy question for you on the test. Please recognize it. And it is on your flowchart. Okay, this is also an old topic that we're trying again. This is absolute value functions. I'm looking for what are called transformations. So I'm referring to movements like right or left, up or down, vertical stretch or compression would be a transformation, and then also a reflection over the x-axis. So this time I put blanks to indicate how many I'm looking for. This number 11, there's 2 different transformations. So this one right here, this is a horizontal shift, and then remember absolute value has that built-in negative in the absolute value part, so that's actually a right 3. Now remember guys, you have a graphing calculator. If you are a little confused, you can always go to Y1, type this in your calculator and look at the picture and you'll see what the shift is. And then plus 7 off to the side is a vertical shift of up 7. So this next one, they put a negative in front. That's its own transformation. That is called a reflection over the x-axis. Sorry for the space issue. And then they put a 4 in front of the function. So that is a different transformation. That is called a vertical stretch of 4. It will make the slope of the branch change, but the actual transformation is called a vertical stretch. All right, and then the third example, there are 3 transformations you have to identify. So the first one is the 0.5 that they put in front. That's the same thing as putting a 1/2 in front of the absolute value. So I know what you're talking about if you call that a vertical stretch of 1/2. The technical term, though, is a vertical compression or a shrink. So I'm going to call it a vertical compression of 1/2. The next transformation I see is this x plus 8. So remember, in the formula, it's x minus h. So if you want to think of it that way, h is really a negative 8, meaning it went to the left 8 units, excuse me. And then this negative 5 off to the side here is the vertical shift of down 5. Again, if you want to try graphing it on the calculator, if you're stuck, that's a good way to kind of confirm that you've done this properly. Speaking of graphing, you should be able to graph absolute value functions. I think they're easier by hand, but you can go to your graphing calculator and get table points as well. So easiest if you first identify where the vertex is located. Remember, opposite sign here because of the built-in negative. So the vertex is located at 2, 5. And then I'm going to plot the vertex at 2, 5. Some of you were plotting your points backwards last test, so be careful. And then whatever your a value is indicates the slope of the branch. And because our a value is also negative, this one's going to go downwards, it's going to be reflected. So the a value is a negative 1 over 3. So for graphing, that means you're going to travel down a unit, and then you're going to go right 3 and also left 3. So down 1, right 3, and down 1, left 3. I can't count. There we go. I don't know if I counted that right. That looks weird. Oh well. And then they are V-shaped. Again, confirm it on your calculator if you're not sure. Alright, so I'm going to kind of let you play with number 5. Check it on the key, please, or check it on your calculator. And then here, I'm going to give you this formula. You just have to know how to use it. So when you are given a graph, and I'm going to try to highlight some points for you on your test, you have to kind of figure out what goes where in the formula. So the vertex is clearly important to us. The vertex is your h and your k. So here's the origin. This ordered pair is located at, let's see, negative 2, oh boy, 1, 2, 3, 4, 5. I can't read my own graph. That's not good. Yeah, negative 2, negative 5. So why is that so important to us? Well, that's because this is your h and this is your k. So we already have two parts of the formula. The last thing you have to figure out is your slope of your branch. Clearly it's a positive slope because it is it's opening upwards. So if you count rise over run from one point to the next point that I gave you, it's going up 6 units over 2 units. So that's going to reduce to a 3. So now here's the trick. You got to put everything where it belongs. So the a value you just calculated to be a 3, and then the absolute value of x minus h would be x minus the negative 2. Notice how it changed to a plus 2. And then you can say plus negative 5 right here. There's nothing wrong with that. But most of you would come back and change plus negative 5 to just say subtract 5. Now these are kind of cool if you want to check. You can just graph this on your calculator, what you came up with, and compare it to what it was supposed to look like and make sure that it matches essentially. Alright, so here, I'll do one more. Let's do this one. The vertex is at, let's see, here's the origin. Over 1, up 1, 2, 3, 4, 5, 6. So we just found our h and our k. And then your a value, I can tell this time it's going to be negative because the shape of the graph is opening downward. It's been reflected. And then it's, oops, I'll move over here. It's moving down 1, and then to the right 1, 2, 3, 4. So you have all the pieces, you just got to place them into the formula. So a value of negative 1/4. Is that 4 or 3? I need to change my answer key. Wah wah. Alright, so negative 1/4. And then absolute value of x minus h, which is a 1. And then absolute value closes. Oops, why are my colors not changing? There we go. And then plus k, which is a 6. So there's our formula. And again, check it on the calculator if you're not sure. I think it's a great way to utilize your $150 machine, right? Okay, so that's all old stuff. Please capitalize on the fact that you're getting a retake on it. You want a better score than you had last time, or if you already had a 5, make sure you're still awesome. Okay, now these are the new guys. These are the piecewise functions. Piecewise functions are crazy, and they have several pieces to them, and I like to color code my piecewise functions. This function is a 5x minus 3 if your x's are less than 0, and if you get less than or equal to 0. If you get a little confused with your less than signs, you might want to literally write down the words less than. The other piece of the piecewise function is negative 5x plus 1, and that is only for x's that are greater than 0. So this question says, what about if you're evaluating your function at x equals 5? So first task is you have to realize what they're asking you to do. They're asking you to plug in a 5. So is 5 less than 0 or greater than 0? And the answer to that is it's clearly greater than 0. So you're going to use your bottom function, your red function there, and you're going to go ahead and plug in the 5. So negative 5 times 5 plus 1 is negative 24. So what if I wanted to evaluate that same piecewise function at negative 1/2? Well, negative 1/2 is less than 0, so I'm going to be using this top blue function. So 5 times negative 1/2, and then minus 3. Let's see, that's negative 2.5 minus 3, so how about negative 5.5? So you just have to make sure you're using the right function. And then what if I'm exactly equal to 0? Well, because this top function had the equal to bar for 0, we're going to use that top function this time. So 5 times 0 minus 3 gives me negative 3. So when evaluating a piecewise function, you have to make sure that you're looking at the proper part of the domain. I'm going to leave number 18 for you guys to try on your own. Please check your answer in the answer key. And now we're going to graph. Alright, so stick to a process that works for you, and for most kids, one of the major things that helps is if they highlight the boundary line. So in this case, it's at negative 3. So marking up our boundary line here at negative 3, totally nailed it. Alright. It's not part of our function, but it's going to be a helpful way for us to kind of split the function. Another thing that you might want to think about doing is writing the pieces of the piecewise function on the appropriate half plane. So like this part of the function, the 2x plus 7, is for all your x's that are less than negative 3, so that would be to the left side of the boundary line. So I'm just going to write down y equals 2x plus 7 over here. And that's going to be kind of like my final double check when I'm going to graph this. Your other function, which is negative 1/3 x plus 5, is on the other side of the boundary line. Minus 5, excuse me, I don't know what I've said the wrong thing. So that's going to happen all over here on this half plane, from yellow line to the right. Okay, so now what we're going to need to do is actually evaluate some points so we can get a good picture. So for your blue function, I manually make a t-table, but you are welcome to use your calculator's table. You just have to be kind of choosy. Remember, we're only using x's that are less than or equal to negative 3. So you always have to start at negative 3. But then you're going to give me a couple numbers that are less than negative 3. So like negative 4, negative 5, all those would be good numbers to come up with. And then for finding the y value, you have a choice. You could either use your calculator's table. So if you put this into y1 and then looked at the table for these values, it would just spit out the y values, or you could do the evaluation yourself. So you're taking your function, which is 2 times x plus 7. And you're going to figure out what happens when you plug all these numbers in for x. So like 2 times negative 3 plus 7 is 1. 2 times negative 4 plus 7 is negative 1. And 2 times negative 5 plus 7 is negative 3. So that very first one on the boundary line, remember he does exist on the boundary line, so it's going to be a closed circle. Everything off the boundary line is always just a regular point. So at negative 3, 1, start off with a closed circle, and then plot a point at negative 4, negative 1, negative 5, negative 3, oops, there we go. And then you should be creating a ray. So from the boundary line outwards, oh man, I was doing the wrong color this whole time, guys. It's supposed to be blue. There we go. Well, that didn't make it any better, but there we go. So this is a line, and if you kind of thought about it, a slope of 2, and it would have had a y-intercept of 7. So if you kind of extend it mentally, yeah, it would have eventually crossed up here at 7. But because of the boundary line, it's restricted and it's cut off. Alright, same stuff. Let's do a set of points for the red function. The red function only exists for x's that are greater than negative 3. So even though it doesn't actually exist at the boundary line, you still got to figure it out. And then you can really pick any numbers you want that are greater than negative 3. Because I'm doing this mentally, I'm going to try to choose numbers that are nice with the fraction of 1/3. So like 0 is always a good number to choose that's bigger than negative 3. And then how about like positive 3? So literally anything bigger than negative 3 would work here. So from here, you're either going to mentally plug all these numbers into your function, your red function this time, or you're going to use your calculator. So if you're using your calculator, you're going to have to go back, change y1 to this function now, and then look at your table with these new values specifically. But you know, I can handle a little mental math today. So it's negative 1/3 something minus 5. All right, let's figure out what's going on here, guys. If you plug in a negative 3 right here, negative 1/3 times negative 3 is 1. 1 minus 5 is negative 4. If you plug in a 0 right here, 0 minus 5 is negative 5. And if you plug in a 3 right here, negative 1/3 times 3 is negative 1. Negative 1 minus 5 is negative 6. So this is a nice double check for us. What we're about to plot should create an array. This first ordered pair, remember, was not equal to, so we're going to have to use an open circle on this first one. So negative 3, negative 4, open circle. And then let's plot normal points from here on out. So 0, negative 5, and 3, negative 6. And yeah, I mean, I know I don't have the greatest graphs in the world, but that one was pretty stinking linear, so go me. All right, so a couple things we double check for our piecewise function. This blue line should kind of match up with this blue function. This red line should match up with this red function. Yeah, crossed at negative 5 has a slope of negative 1/3. Awesome. The rays should be going in opposite sides of the boundary line. They shouldn't be on the same side ever. And yeah, that problem took us a long time. I agree. That was tough. All right, and then real quick here, guys, I'm going to move on to circle. I'm going to give you this formula. You just have to remember how to use it. So the center, remember, is located at HK. But there are built-in negatives this time on both the y and the x because they're set in parentheses with built-in negatives. So this time you got to think opposites for both h and k. So the center is going to be at 9, 6, and the radius is the square root of this last number because remember 81 is r squared. So if you square root 81, you're going to get a 9. That's what the radius is. So here, h is actually a negative 5, remember the built-in negative, and then positive 3, built-in negative again. And then the radius is the square root of 4, which is a 2. So that shouldn't be too tricky. Now what if I go in the reverse order and I give you the h and the k, and then I tell you the r, and can you give me the formula? So the formula is x minus h, so that'll change to x plus 2, quantity squared, plus sign in the middle here, and then y minus k, so 5, quantity squared, don't forget that, I did give you the formula, and then equals r squared, so instead of writing 7 squared, I want you to write that as 49, please. Alright, I'm moving along to one more where I give you the circle, which is kind of like giving you h, k, and r, you just have to identify them. So like the center is your hk, that's located at 1, 1. And the radius, you're just going to have to count. So 1, 2, 3 units. So our formula is x minus 1 squared plus y minus 1 squared equals 3 squared, which is 9. All right, check the answer key for anything else you needed answered, and good luck on your test.